With Spring Boot, it's pretty easy to build these type of applications. Mostly, you just have to talk about serving static resources. So you can take a Spring Boot application and serve resources from your jar very easily. To serve resources, you simply put them in a well-known location. So in the source main resources folder in your build setup, you can either have resources, public, or static, or any combination of them, and these resources will simply be served directly to the browser. You can also package these into nested jars. Nested jars are just a way of combining useful assets and serving them up in a way that you can build a complete application from them. Another option is web jars. Web jars are simply nested jars that have been published by a third party. So these are things like jQuery, all your standard JavaScript libraries, and they've been packaged up with a particular version number and put into Maven Central so that you can just consume them. One more thing that you can do is add a favicon, which is just the icon file that gets displayed in your browser. Again, you can put these in any of the standard locations, source main resources, and then resources, public or static. As I mentioned earlier, it doesn't matter where your resources come from. You can build up a specific jar that just contains the assets. This means it's really useful, and if you want to use JavaScript build tools to create those asset jars, this is a possibility. JavaScript tools offer a lot of advantages. For instance, there's a lot of processing tools that you might want to use. You can take a less file, which is a kind of extended CSS file. You might have JavaScript processing, minification, uglification, obfuscation. You might have image processing, taking a ping file and maybe creating different asset sizes for Retina displays. These kind of things all take tools, and the tooling in the JavaScript world is much more complete than you'd find in the Java world. You can also use tools like Gulp and Bower. Gulp is the build system and Bower is like the dependency management side, so you can consume JavaScript libraries and make that part of your build process as well. In this example here, we're showing how we've got 3 input files being processed by Gulp, we've got some external libraries coming in from Bower, and the resulting output is a jar file that just contains resources in the right place. And remember, a jar file is just a zip file, so these are pretty easy to create. So why build with JavaScript? JavaScript is a very vibrant ecosystem, and remember that most of web application development happens in the browser first, so you tend to find that cutting-edge tools happen in JavaScript first. Your front-end developers will also probably prefer it. It's also an excellent place to write tests for your JavaScript. You can hook into some of the test frameworks that are available and write actual client-side test code as well. Let's have a look at a demonstration of how you can serve resources with Spring Boot. So here we have a simple Spring Boot application. There's nothing much to it. If we open up the main application file, you can see that we've got the standard annotation and then nothing more than a main method. So this is going to start up the web server. If we look at the actual source folders, we have source main, and then under here, resources. We have public, we have a resources folder, and we have a static folder. And this is just to show that you can mix and match these things. So let's have a look at the public folder. This has just got one index.xml file, which is going to link off to 2 other examples. We've got one that's using WebJars and one that's using Bower. So when we start this application up and head over to a web browser, we can hit the root URL and that's automatically mapped to the local index.html file. So let's do localhost 8080. And there we see the HTML served straight up. You'll notice as well that I don't have to put index.html into the URL, although I can if I want to. This is a convention that Spring Boot applies, so any index.html file will automatically get mapped to the root of your browser, unless you have defined your own. Let's have a look at the WebJars example. So this page just links off to the WebJars HTML file, and that's in the same folder. And here we're doing a little bit of JavaScript. So I've got a couple of imports, script imports, and these follow the WebJars convention. So anytime you see /WebJars, that means that that script is going to come from a Maven dependency. And then here we have jQuery, the version number, and the actual file we want to import. I'm also importing a JS file, which is in my resources folder. So here you can see /JS querylettering.js, which matches to this file here. And then the actual HTML is fairly simple. We've just got a bunch of text and some startup scripts that's going to add a nice effect. If you want to actually declare the dependencies to WebJars, you do it in the same way as you would any other dependency. So I'm using Maven here, and I'm using the jQuery import. So this is the only dependency that I need to apply. There's a nice website, webjars.org, that shows you a whole list of all these things, but pretty much any of your standard JavaScript dependencies are available. Okay, let's click that link and see what it looks like. So here you can see that that text is being applied with a nice kind of style sheet to it, and the JavaScript's giving us that nice effect. If I enable the network traffic, we can actually see what files are being loaded. So here I'm using Firebug, which is a little plugin for Firefox. If I click the network panel, enable it, and then refresh this page, you'll see that the queries are being all made to localhost, and then the appropriate files are being served directly from Spring Boot. Let's have a look at the other example. So let's try this with Bower. If I click the Bower link, we're going to get the same kind of output, but this time we're not going to get the nice effects. And we can see that this is because jQuery hasn't actually been resolved. This is because I haven't actually ran the Bower process yet. So this is normally an additional step that you need to do outside of your Maven build, or something that you need to plug into Maven to have it call Bower explicitly. I'm just going to do it from the command line so you can see how it works. So here's my project. And if I look in the source, we can see that there's a bower.json file. There's also a hidden file, bower.rc file, and these two in combination tell Bower how to work. Let's look at the bower.rc file first. So this just simply says, Bower, when you download stuff, I want you to put it in source main resources static lib. And because static is one of the predefined locations, then any files that end up there will just serve and work. If we look at the bower.json file, this is the equivalent of the Maven POM in the Bower world. Here we're just effectively saying, I want jQuery and a specific version, so in this case 2.1.3. If I run Bower now locally, and then type install, this goes off, gets the dependency from GitHub, puts it in the local drive. So if I go back to my Eclipse, shut down the running process, refresh that folder, we should see now in the static lib folder we have jQuery and the particular version that we want. And if we look at the Bower files, the Bower HTML that we've declared, here you can see the same sort of script import, but this time we're just calling JS jQuery lettering and lib jQuery dist jQuery.js. So this maps to the format of the folders that Bower creates. If we run this application again, and then flip back to our web browser, this time we get the nice effects and we see that all the scripts have loaded up and we haven't got any kind of 404 errors. Let's talk about how you call your microservice from a rich web application. So normally a web application will call what's known as a front door service, which will in turn coordinate all the microservices that you've got sitting behind it. This is sometimes known as an edge server. You're probably going to use REST to call that service, although sometimes you might want to use WebSockets as well. And how will you actually call those services will depend on your JavaScript framework. For instance, with Angular, they give you an HTTP object, so you can do HTTP post some particular URL and give it a payload, which is normally JSON. We can have a quick demonstration of how that looks in Spring Boot by taking an Angular demonstration from the web and repackaging it. So this application is taken from a website called scotch.io. It provides a number of tutorials, and one of them is an AngularJS tutorial. What I've done is taken that application, which is normally a Node application, and rewritten it to work with Spring Boot. So the actual client-side code is exactly the same. I've just tacked on an additional server. Let's have a look at the client code first. So here's a typical Angular application. We have an index.html page, a whole bunch of markup. The important things here are just the scripts that it imports, and then the body is fairly kind of simple. This is a to-do application, which is the standard kind of example that you get with most web frameworks. If we jump into the JavaScript, we can see how the REST calls are actually made. Let's look at the main JavaScript file first. So this declares a number of different methods that are called, and the ones that we're looking at are the to-dos method. To-dos here is a service that's been created, and then these are the methods that you can call on that service to perform actions on the to-do list. So this is like a to-do list that's backed by a REST service, so you can imagine it being persistent. You could close your application, come back to it later, and your to-dos are still there. So here we have a create method, we'll have a delete method. All of these are actually defined in the todos.js file, and this is really simple to look at as well. We have a service name, to-dos, here's the Angular HTTP object, and then these are the methods that we can call on it. So for instance, a get method will call HTTP get with this specific URL. Create does the same URL with the data, and delete gives us the same URL but with an ID tacked onto it. All I've had to do to get this working with Spring Boot is change the REST controller from a Node application to a Java one. So if we look at the main application code, you'll see this is exactly the same. But I've added a to-do controller and a to-do object. The to-do object is just a simple data holder, so it declares an ID and some text, and then I'm using Jackson, so I've got some annotations to tell it how to bind things. One of the nice things about Jackson is you can declare these annotations and create immutable objects. So in this case, the text doesn't change. If we look at the controller, this is just a standard Spring MVC REST controller. So here I'm saying I want a REST controller. This maps to the URL that the FAT client is going to call. And then I'm creating a kind of scrappy implementation where it holds the to-dos in memory. So these three methods relate to the three calls that we saw in the other service. Get will simply return a list of them. Post will add a new item to the to-do list, and delete is called to delete them. Let's run this application. So application started up, and if I go back to the web browser, I'll close this Network Tools now. If I refresh the application, you see we get I'm a to-do-aholic, and I can start to just add items to this to-do. If I reopen the Network Tools, we can see the traffic that's happening. So let's just refresh that page. You can see that I refreshed, but the items remained. And somewhere down here we'll have a get call, so get to-dos here. We can look at the method call here, and the response is JSON, so in this case we're returning those two text items that we declared earlier. If I click on delete, so by checking a checkbox, you'll see that we get another call. And this time we get the ID that we want to delete, and the response is simply the data that's left. So the exact way that you'll tie up your JavaScript framework will be different, but you can see that the general idea of having a rich web application that talks REST is pretty easy to put together.